All right, so we are going to be working this week on a few lessons that, like I said, are specifically tailored for Indiana standards. And today we're going to be talking about outcomes of compound events. And a compound event, it sounds all fancy, but all it means is more than one event. So if you flip a coin and you roll a dice, that's a compound event. Event 1 is that you flip a coin. Event 2 is that you roll a dice. Okay. Yes. Oh, okay. So event 1 is that you flip a coin. Event 2 is that you roll a dice. And then since it's a compound event, you have multiple outcomes. And I'm going to show you today how you can determine how many outcomes you should have when you have these multiple events. And you can have more than two events. You can flip a coin, roll a dice, and draw a card from a deck of cards. Okay, and then you would have a certain number of outcomes that you could, maybe you roll a 2, you flip a head, and you draw the King of Hearts, right? That's one possible outcome. And you can see, especially since the deck of cards is so big, how many possible outcomes that there could possibly be. Okay, all right. Maybe at the end, we'll do a little bonus fun question. You guys can tell me how many possible outcomes. And by the time we get to the end of the hour, you'll be able to do it easy peasy. All right. So let's look at this first example. It says Cameron packed 2 pairs of shorts and 3 t-shirts for a weekend trip. What are some combinations of shirts and shorts that Cameron can wear while on his trip? How many days will he have a different outfit to wear? So just randomly, somebody tell me what is a possible outfit that he could put together. Easton? White shirt, green shorts. Good. Somebody else. Mallory? Yellow, blue. Zach? Red and blue. Somebody else. Yes. Red and green. Somebody else. Mia? Yellow and green. Have we said them all? Anybody know? White and blue. Have we said them all? Kind of hard to keep track, right? But I'm going to show you here in a second how we can easily keep track. So all of these are combinations of outfits that Cameron can put together. Now, rather than being random like we were, which we were purposely random, that's the way I wanted it to be, I'm going to show you how to do it a little less random so that when you go to list all these possible outfits, you make sure that you don't forget one and that you don't accidentally duplicate one. Okay, so there's a couple of different ways you can do it. You can do a tree or a table. Since there's 2 events, and what I mean by events is there's your choice of shirt, that's your event 1, your choice of pants, that's your event 2. Okay, since there's only 2 events, anytime there's 2 events, I like the table the best. I think it's the easiest one to do. It's the one that's the most organized. So that's what we're going to do first. And I'll show you how you can do a tree, and then we'll go on with some other examples. Okay, so if we're going to make a table, the way you make a table is you do event 1 along the side, and it really doesn't matter if you do it along the side or along the top, and I'll show you that here in a second. So we're going to do event 1, and everybody should be doing this in their notes, across the top or across the side. And in this case, event 1 is our shirts. Okay, so if I draw a little line here, I have yellow, I have white, and I have red. Those are my possible colors for my event 1 or my shirts. Then across the top, we have event 2, and event 2 is our shorts, right? And in this case, our shorts are green and blue. Those are our possible colors of shorts. And it sounds weird thinking of your shirt color as an event, but when you pick your shirt color, that's considered event 1. When you pick your shorts, that's considered event 2. Now I'm going to go ahead and draw some lines in here so that my table actually looks like a table. And then I'm going to fill in my table, and I'm going to use letters for abbreviations because, well, I always tell you guys I like I like numbers, not letters. So I'm going to write as little as possible wording wise. So I've got a yellow and a green, a yellow and a blue combination. Then I go to the white shirt. I have a white shirt with green, a white shirt with blue shorts. Then I go to the red shirt. I have a red shirt with green and a red shirt with blue shorts. So now if I have to list the possible combinations, I know for sure I'm not going to forget any and I'm not going to duplicate any because I can just go through and say yellow, green, yellow, blue, right? White, green, white, blue, red, green, red, blue. It's very organized, very neat. How many possible outfits do I have? Yes. 6. I have 6 possible. So the answer to the question, how many days can you wear a different outfit? The answer is 6 possible. I'm going to put outcomes. In this particular case, it's clothing outfits, but in every case, you can always put outcomes. Now, I do want to show you a little bit of a shortcut in how you find your number of outcomes, not listing them, but your number of outcomes. I had 3 shirts. And let me do that a little bit different. What do you need, Sean? That's what we're getting ready to talk about. So a little bit of a shortcut is for the shirts, I have 3 possible options. For my shorts, I have 2 possible options. If you take 3 times 2, you get 6. So if you are just asked, what is the number of possible outcomes, you can use this multiplication strategy in order to find it a whole lot quicker than coming up with a table. Now, you obviously are going to want to read the directions in your homework, because it might say what are the possible number of outcomes and then list those outcomes. And if you have to list them, you need to do some sort of organized way to list them. And we're going to talk about 3 of those. There's a table, a tree, and just a list. Whose is that? You're going to have them in here, guys. If this keeps happening, I will shut down the backpack deal and you will have to somehow make it back to your lockers. Okay. So let's make sure that we're not having any noises interrupting class. There is a table, there is a tree, which we're going to talk about here in a second. And then there is also a list that we can actually make from the table or the tree. Okay. The tree, you can either do it up and down or sideways. It doesn't really matter. If you go up and down, your tree would look like this. You would say you have a yellow, a white, you start out at least, and a red, kind of similar to the table. But instead of drawing a grid, we're actually going to draw branches. And with the yellow shirt, we have the option of green and blue. With the white, we have the option of green and blue. And with the red, we have the option of green and blue. So you can see how green and blue gets written 3 different times. It gets written once with the yellow shirt, once with the white, and once with the red. And this is a tree. Now, you still end up with 6 possible outcomes. You have, let's kind of highlight them just so you can see where my eyes are going. Your possible outcomes, just the same as your table, was, yellow green, which was here, yellow blue, which was here, right? Then we had white green, which was here. You had white blue, which was here. And then you had red green, which was here. And you had red blue, which was here. You can see that you get all of the same possible outcomes. It's just laid out in a different way. Yes.
Last year, but I don't think we did the table. The table stays weird.
I do too. Yes. It works with 2 events, 3 events, 4 events. It works with everything. Yes. Okay. So what I mean by it works with more events, and I'm actually glad you asked that, because that kind of leads into what I was going to say next. What if I throw in shoes? What if I say that Cameron also brought running shoes? Whoops. What if I say that he bought running shoes and he brought flip-flops? And with that, how many possible outfits could he make? Writing is hard. All right. So if we did that, we would add his shoes, and he has 2 possible outcomes for his shoes. Well, now we have 12 possible outcomes. So you can do that as many as you can have as many events as you want. Yes. 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 So because a table has an X and a Y axis, right? If we added the shoes, we could not do a table, because you can't have a 3-sided table. You can have an X axis and a Y axis. You can have a side event and a top event. Okay. You don't have a spot for a 3rd event. So if it is a 3rd event, and we're going to talk about that next, if it's a 3rd event, you have to do the tree. Okay. You can't do a table when there's more than 2 events. Okay. Because what we would do if we were to add the shoes, and I'm not going to take the time to do it, but if we were to add the shoes, we would go from green and we would do running shoes and flip-flops. And then from here, we would do running shoes and flip-flops. And we would do that each time. And we would give each one of the 2nd event we would branch it out into a third event. Okay. And that's why you can't do it in a table. That's why you have to do that in a tree. All right. That jumped a little bit ahead, but I purposely wanted to jump ahead because now when we see it in the notes, I'm going to refer back to our shirt and shorts question. Now, before we turn the page, it says, how would the number of different outfits change if Cameron packed a pair of khaki shorts as well? Now, we're not going to do a table or a tree to answer this. We don't need to. How many possible outfits do we have if he packed a third pair of shorts? Carson? 9. We have the 3 shirts times now the 3 shorts would give us a possibility of 9 outfits. Okay? All right. So now let's look a little bit closer at the tree. Okay? We're going to look at this example that utilizes a tree. And the reason we have to utilize the tree is because this is considered 3 events because we're talking about 3 children here. Okay? So child 1 is the first event, child 2 is the second, and so on. So it says, Haley has 2 sisters and no brothers. Josh has 2 brothers and no sisters. They wonder what the chances are in a family of 3 children, all of the children will be boys or all girls. How can they determine all the possible combination of boys and girls in a family with 3 children? Now, because there's 3 children, that's 3 events. We can't do a table. We have to do a tree. And this is an example of right here. Right here, it's called a tree diagram. Okay, so if we look at our children here, we've got child 1. Okay, that's right here in the tree diagram. With child 1, there's only 2 possible choices, a boy or a girl. Okay, that is event 1. Okay, then you move on to event number 2 right here. Okay, child number 2. With child number 2, you have 2 choices. Now you'll notice that on the child number 2 level, you have more footprints because one spans from the first child being a boy, and then you spread out to boy, girl. The other side comes from the first child being a girl, and then it spreads out to boy or girl. So your possibilities double, okay? Then when you get to child number 3, different color here, go. When you get to child number 3, go. Sorry, it always gets so light for some reason. There we go. Child number 3. And here's the child number 3 level. Again, notice it doubles again. Okay, you've got from each second level child, now each one of those branches out into the boy-girl option as well. And so we end up with, right here, we end up with all of these possibilities. Okay, you can have all 3 boys, which is right there. You can have boy, boy, girl. You can have boy, girl, boy, and so on and so on, okay? And each one of them goes down into those possible options. What I highlighted in green or in purple there is called the sample space. And I want everybody either highlight or underline the word sample space, please. And then underneath it, I want you to write this right here. This is the definition of a sample space, okay? All possible outcomes. Everyone, please add that to your notebook. The sample space are all possible outcomes. And so if we were asked to list the sample space, we could do it in a very orderly fashion now without, I mean, if I just tried to randomly say, okay, what are the possibilities with 3 kids? And everybody starts saying boy, boy, girl, girl, boy, girl, boy. That would get very, very confusing very quick. So this is a way to organize it so that when you get to the end, you know that you've got every possible outcome without any duplicates. Okay, you haven't missed any and you haven't duplicated any. Now, I do want to point out, could we do a quick check that 8 is the proper number of outcomes, that our tree is right? We can use that multiplication principle that we talked about earlier, because for child number 1, what are the possible outcomes for the first child? Boy or a girl? So there's what? 2. Then you get to child number 2. Just for child number 2, as a standalone event, what are the 2 possibilities for child number 2? 2, boy or a girl again, right? Then you get to child number 3 as a standalone event, not even thinking about the other 2, just thinking of child number 3. The possibilities for child number 3 are boy or a girl, right? 2 again. If you take 2 times 2 times 2, what do you get? You get 8. So it does pan out that is there 1, 2, 3, 4, 5, 6, 7, 8. Yes, there is. Okay, there are 8 possible outcomes for the order of boy, girl when you have 3 children. Okay, if you threw in a 4th kid, now how many outcomes could you have? Very nice, 16, because the next event would be 2 again, and so you would just keep multiplying it by 2. Okay, it doesn't always double. The reason it always doubles here is because each event only has 2 options. If you throw in an event having 3 or 4 options, or like a dice that has 6 options, then it wouldn't just double every time. It would get much bigger quicker. But because each event here can only have 2, kind of like flipping a coin, there's only 2 options when you flip a coin. It's heads or it's tails, right? So if you flip a coin a bunch, those events would always double as well. Okay, so now I want you guys under this try it, and we just talked about flipping a coin, so this should not be too terribly hard. At the bottom of page Indiana 8, I would like for you to fill in the missing information for this heads, tails thing. Okay, but then I want you to go a step further, and I want you to add a column for sample space. And I would like for you to list the sample space of what you would get if you flipped a coin twice. Event 1 is the first flip, or quarter number 1. Event 2 is the second quarter flip. All right, somebody that hasn't answered a question yet today, tell me what I would put under quarter number 1 in that second box. Sean? T for tails, good. Okay, somebody else that hasn't answered yet today, under quarter number 2, what would I put in that first box? Kaylin? What is it? T for tails, good. And then Tyler, what would you put in that next box? H, good. Now we want to list the sample space. And to list the sample space, you kind of have to follow your tree and look at all your possible options. And thankfully, there's only 2 events, so your tree is pretty small, right? It makes it nice when your tree's that small. You've got heads is your first possible answer in your sample space. Then you've got heads, tails. So your next possible event in your sample space would be heads, tails. Then you move on and you've got tails, heads. So tails, heads is your next possible outcome. And then last, you've got tail, tail. And so your last possible outcome in your sample space would be tail, tail. So that is what you would come over here and put as your answer. So where it says list your sample space, go ahead and do that. That's these right here. So heads, 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 tails, tails, heads, and tail, tail. Okay, are we good with sample space? It's really just a mathy term that means total number of possible outcomes, okay? All right, so how does the sample space change if the number of quarters that is flipped increases by 1? What would happen? So you've got quarter number 1. How many possible outcomes are there for quarter number 1? Mallory? 2. Then you flip quarter number 2. How many outcomes possible are there? Somebody else. Alex? 2. Now, if we increase our quarters by 1, we add a quarter number 3. How many possible outcomes are for quarter number 3? 2. So now what are our possible outcomes? 2 times 2 times 2 is 8. What if I added quarter number 3? Right? It would keep doubling. Quarter number 5, what would happen? Doubles again. Good. It would be 32. You just would keep going on and on from there. We're not going to keep going. Okay. Everybody good with that? To use the math option or that multiplication principle, you take the possible outcomes of event 1 times the possible outcomes of event 2. And if there's a third event, times the possible outcomes of event 3. All right. Okay. Not going to spend a whole lot of time on example 2 because quite honestly, we've already talked about everything here. It says a game is played spinning 2 spinners. Players match the results of the spinners to combinations on their game cards. How many different combinations are possible? Well, first of all, we can use that multiplication principle to say right off the bat, if spinner 1, I'll do it color coded. Okay, here's spinner 1. Spinner 1 has how many possible outcomes? How many letters are on there? 6. Good. Times the number of outcomes. Here's spinner blue. Okay, how many outcomes are there for spinner blue? 6. So how many total outcomes are there possible? It's multiplication. What is it? 36. 36 possible outcomes. You can answer that without ever doing a table or a tree or anything else. Okay. Now, 2 events, which means a table is the best way to do this because that would make one ugly tree. I would not even want to think about having to try to do that tree. But as a table, it's super easy. Okay. When you're doing a table, notice that this is spinner number 1. Keep this color coded here. This is spinner number 1. Okay. And this one up here is spinner number 2, or the blue spinner. Always put one event along one side and one event along the other. Okay. And I've seen it happen today. A lot of people will put 1, 2, 3, 4, 5, 6 across the top, but along the side, they put spinner 1 and spinner 2. That's smushing 2 events on one side of a table. You cannot do that. Spinner 1 is its own separate event, so it gets its own side of the table. Spinner 2 is its own event, so it gets its own side of the table. And if you were to throw in a third event, you couldn't do a table anymore, but it would get its own branch of the tree, right? Each event either gets its own branch or its own side of the table, okay? So that's that multiplication right here, this multiplication counting principle. We've already talked about that, and we've already talked about how to set up a table, so I'm really not going to spend much more time on that one. Any questions on that? All right, go ahead and go to example 3 because there's something very specific I want you to put in your notes for example number 3. Oops, forgot to erase this from earlier, sorry. On example number 3, I want everybody to write this in their book. Under where it says list in the title, it says use an organized list, and really organized is part of it too. So it's an organized list. Okay, use an organized list to represent the sample space. I want you to write I call them fancy brackets, whatever, the fancy bracket. And then inside that, I want you to write the words parentheses and commas, and then close it with another fancy bracket. The reason I specifically want you to write this is as a reminder, when you are asked to do a list, okay, it almost looks like ordered pairs when you're doing an X. If you think about an X and a Y chart, right, a table, each time you have an X and a Y together, they create an ordered pair. Basically a table, when you have this axis is event 1 and this axis is event 2, every square where they intersect creates this ordered pair. And that's how you would write it. So if you look here as your example, first thing I want you to notice is that it starts right here and ends with those fancy brackets. One at the very beginning, one at the very end. That tells you that everything in the middle goes together. Okay. The next thing I want you to notice is that each event is in its own, right here. This is one outcome. It's in its own separate parentheses with a comma, and then it's separated by a comma from the next one. So this one is its own outcome, right? This one is the next outcome, and so on and so on. So it's very important that when you see the words, show your answer or state your sample. What is it? I just now lost it. Totally went out of my brain. Sample space. I don't know why the word space was just jumped out of my brain, but it did. Anytime you're asked to show the sample space as a list, please remember parentheses and commas. Okay, you have to use parentheses and commas. And if you want to even make yourself a little bit more of a note to get more specific, you want to think of them as ordered pairs. Okay, that's how you want to write your list. You want to think of them as ordered pairs. Okay. All right, so if we look at, I'm going to erase this where I was talking here. If you look at this event here, this compound event, you've got rolling a dice, and it tells you right here that there are 6 possible outcomes when you roll a dice. That makes sense. There's 6 sides. And then flipping a coin. Okay, flipping a coin has 2 possible outcomes. So right off the bat, before you even worry about a list, how many possible outcomes are there? 12, because 6 possible outcomes of event 1 times 2 possible outcomes of event 2, 6 times 2 is 12. So we know right off the bat, and it's right here, we know that there are 12 possible outcomes, but they ask us to list them. And sort of like at the beginning of class, when I started asking you guys to list possible outfits, if you don't do it in an orderly fashion, you're liable to miss one or duplicate one. So what I would highly recommend, if you are asked to make a list, it does not take but a minute. Create a table, okay? It will really help you to keep everything orderly and you won't miss one or duplicate one. So what I would do is I would say I'm rolling a dice. That's event 1. So that's going to go down the side. Remember I said event 1 gets its own side. Okay, there's event 1. Event 2 is heads or tails. Well, if I do event 1 across the side, I'm going to do event 2 across the top. So heads, tails. Now I'm going to draw some lines here to make it look like a nice orderly table. Everybody should be adding this table to their notes. Now it's pretty easy to fill in, right? 1H, 1T, 2H, 2T, 3H, 3T, and so on. Continue filling in the table. 5H, 5T, and 6H, 6T. Now that is a table representation, right, of the possible outcomes. And now I can take that and I can convert it into a list, which is right here, by taking each possible outcome and putting it in the parentheses and adding the commas and all of that. But you're not going to actually do that in the table. The table is just a tool that you're going to use to kind of keep your thought process straight. So when you're asked to do a list, I would do the table, but then come off to the side, and this right here is the actual answer that you would circle. Start with a fancy bracket, start parenthesis, comma, until you get them all listed, and then end with a fancy bracket, okay? All right, I want you guys to do the try it. That's at the bottom of that page. Okay, so if everybody would scoot their eyes down to the bottom, what page are we on now? Are we 9? I don't want to scoot it up because I've already got the answer written, so that's why I'm not sliding it up. Yeah, so at the very bottom there of Indiana 9, it says you've got a bag that contains tiles A, B, and C. So your bag is event 1, so your bag is going to get one side of your table. Then you've got a box with numbers 1, 2, and 3. So your bag is event 1 with letters. Your box is event 2 with numbers. Create a table. Squeeze it in there somewhere. I've got mine squeezed in next to the word try it, but you can put it wherever you want. Create a table. And then from the table, I want you to practice creating a list. So I want you to do both. I want you to create a table and create a list. Yes.
Put the title on the table for each side.
No, but you do have to put A, B, and C along one side, 1, 2, and 3 along one side. Create a table, and then from the table, create a list, and that means fancy brackets, parentheses, and commas. Create a list from that table. Remember, when you hear create a list, you need to do fancy brackets, parentheses, and commas. Sorry, I did not mean to scare you. I'm so sorry. All right, so what your table should look like now, there's not, don't erase it if you've done it differently. This is what my table looks like. I did my bag of letters across the side and my box of numbers across the top. You can flip-flop that. You can do numbers down the side and letters across the top. It doesn't matter, okay? You're still gonna get the same sample space. So my sample space, okay, looked like that, A1, 2, and 3, B1, 2, and 3, C1, 2, and 3. And then I use that, and here is using parentheses, fancy brackets, parentheses, and commas. That's how you do the list, okay? All right, if you go to the next page, that's just key concepts. That's just a review of what we just talked about. Again, the information that we are dealing with, right? You can either put the information out there as an organized list, as a table, or a tree diagram, depending on the directions. If the directions say a list, do a table first to keep yourself straight. I promise you it will save you a headache. Remember your multiplication counting principle. You can take the possible outcomes from event 1 times the possible outcomes from event 2, multiply those two numbers together, and that gives you the total number of outcomes. Okay. If you guys would, we've got about 5 minutes. We've got time to do both. I want you guys under do you know how? I want you to do number 4A, 4B, and 5. Okay, 4A, 4B, and 5. And I'm going to come around and just kind of see how you're doing on it. So notice 4A just says how many outcomes, 4B wants you to do a table, and then 5 wants you to do a tree. So be mindful of what the directions ask you to do. And then I'm going to go ahead, for those of you at home, if you have any questions, shoot me an email. Your homework is the next 2 pages, numbers 6 through 15, and you can email me if you have any questions.